Whitesides, and I am a trustee of the Blanco County South Library. It is my pleasure to introduce Hunter Williams, Chief Meteorologist at KUTV in Austin. Hunter is from Birmingham, Alabama, went to Penn State University, spent 2.5 years in Macon, Georgia, before arriving in Austin. He has been at KU for a little over 4 years, and he graciously accepted our invitation to talk to us about the upcoming solar eclipse. Hunter?
Perfect. Thank you. I'm glad that this February we've not had any impending ice storms or blizzards, so we've got a little time to talk about the solar eclipse. So I'm happy to be here talking with you guys today. So I've been getting a lot of questions about this solar eclipse, especially as it's gotten closer. It's been a long time since Central Texas has had a total solar eclipse. On average, it's a little over 300 years. Once every 330 years or so, at any given point gets a total solar eclipse. But for Central Texas, it's actually been much longer than that. It's been like over 600 years. So excited to talk about this with you guys. And we'll start with just the basics. What is a solar eclipse? And I'm excited to talk with you guys about this. Normally I'm talking with like kindergartners or first graders. Well, I think this is what happens. So this is how a solar eclipse happens. This is just the diagram. And there's a few things here that we'll kind of familiarize ourselves with as we start to talk more about what to expect during this total solar eclipse, which is on April 8th, by the way. I guess I should have led with that. April 8th is when the solar eclipse is happening. So during a solar eclipse, the moon is lined up perfectly between the Earth and the sun, such that the moon is casting a shadow on the Earth. So in the same way, if you walk outside this afternoon, you see trees casting a shadow on the ground. Solar eclipse is the same thing, except we're getting the shadow on the Earth. So a few terms to be familiar with here. Number one is the umbra. The umbra is the direct shadow of the moon. So here in Blanco and here in Central Texas, we will get really dark, and that's because the umbra is going to be passing directly overhead. Now, another word to keep in mind is the penumbra. That is the more indirect shadow of the moon. So although we get kind of the real deal totality here in Central Texas, other parts of the state and other parts of the country will get a partial solar eclipse. It will get a little bit darker, but not completely dark. They will be under the penumbra. So just a few terms to keep in mind as we keep going. And also, just for reference, a lunar eclipse would be the opposite, right? So we have the total solar eclipse, but a lunar eclipse would be instead of the moon casting a shadow on the Earth, now the Earth is casting a shadow on the moon. What that normally looks like is the moon will have kind of a reddish or orangish tint to it. But for today, we'll focus on the solar eclipse. Now, one of the big questions I've been getting is, wait, I thought we had a solar eclipse back in October. What's the difference? Why is this one going to be so much cooler? Well, we had a partial solar eclipse back in October, and here for Blanco and points down to the south and southwest, it was an annular solar eclipse. And this brings up an important topic with solar eclipses, and that's that there are three main types of solar eclipses. So it's important to know the differences. A partial, an annular, and a total solar eclipse. During a partial solar eclipse, just as it sounds, part of the sun is going to be covered up by the moon. So in Austin, for example, with this last eclipse, which was back in October, we did not get annularity. We had a partial solar eclipse. So about 89% of the sun was covered up by the moon. Then you get to an annular solar eclipse. That is when you get that ring of fire effect around the moon. So we'll talk more about the orbit of the moon and how this happens, but that's when you get the ring of fire effect, an annular solar eclipse. And then a total solar eclipse is by far the coolest version of that. That is when not just part of the sun is covered up, the entire sun is covered up, and you get the cool twilight or nighttime effect during the middle of the day, which is what we are going to enjoy here in Blanco in just a couple of months. So our last eclipse of any kind that we had here in Central Texas was back on October 14th, 2023. This is a picture that I took outside the apartment where I live, where we got these really cool shadows. So did you guys see shadows that looked like this? So we're going to talk more about kind of the different effects that the lighting during an eclipse, what kind of different things that can create. But this was one of the cool things that we will see again, because we didn't have an orb in the sky, right? We basically had a crescent. we got these cool crescent-shaped shadows. And another side effect is that during solar eclipses, instead of a broad orb giving you kind of these fuzzy shadows, right? If you look outside for shadows today, it's going to be kind of a fuzzy outline. You get more of a direct light, so the shadows are actually crisper. We're going to talk more about that. I just wanted to show you this picture from our last partial solar eclipse. Now, in Austin, where I was watching this eclipse, we did not experience annularity, so I did not get to see the ring of fire, but Blanco and just down to the south, it was annularity. So this is what it would look like if you had a very strong telescope. You were able to look up and take a photograph of this. So the dark part, that's obviously the moon, which is covering up most of the sun, but you get this ring of fire effect. So we know that the moon obviously is orbiting around the Earth, but this is not a perfect circle. The orbit's not a perfect circle. It's more of an oval, so we call this an elliptical orbit. And what that means is that at certain points, the moon is a little farther away or a little closer to the Earth. And based on that distance, that determines during the eclipse, is this going to be an annular solar eclipse or a total solar eclipse? So when the moon is a little bit farther away from the Earth, that's when you get this annular solar eclipse, because from our perspective, it's not in a position to cover up the entire sun, it's covering up most of it, you get this ring of fire effect. So this is an example of the annular solar eclipse. This was the path of the annular solar eclipse. You can see it crossed over a good chunk of Texas that went into the kind of Four Corners states, Nevada, and then up into the Pacific Northwest. What's really interesting to me is that this path is going to be intersected by the path coming up in April for the total solar eclipse. So it's just kind of cool to me that we have these two different eclipses which are in some spots intersecting. So to just kind of broadly answer the question, why is this eclipse going to be much cooler than the one that we had back in October? It's not just going to be a partial eclipse, it's not just going to be an annular eclipse, it's going to be a total solar eclipse, and by all accounts from people who have experienced both, this is just way, way, way cooler, way more impactful to experience for yourself. So how rare is a total solar eclipse? It turns out they are pretty rare. This is another question that I've been getting. Anywhere on the Earth, so anywhere. On average, this happens every 18 months or so, about every year and a half. We do not live anywhere on the Earth. We live right here in Central Texas, though, and for any given spot, it's a lot more rare. So for any given city, a total solar eclipse happens about every 360 years to every 410 years. So nobody in this room has experienced a total solar eclipse here. Now, for me, in 2017, there was a total solar eclipse that impacted parts of the East Coast. I was in Macon, Georgia at the time, and I was just outside of totality, but I experienced, it was like 98% totality. And even that was really, really cool, and you got some of the effects where, okay, the temperature drops a little bit, the animals start acting like it's nighttime, so we got some of that. I actually got to watch this at a place called the Okmulgee Indian Mound, so there's kind of this cool, like, spiritual aspect to it, too. And that was really cool, but this is going to be even better. So, once every 360 years. The last time that Austin experienced a total solar eclipse was much longer than that, and I can tell you the skyline probably didn't look like that. It was May 26th, 1397. So it's been a long, long time since Austin or Central Texas has experienced a total solar eclipse, which is why I'm really glad and we're all very fortunate that we get to experience this. So the path of totality, where's this eclipse going to cross? This is the path for the entire United States. So it's going to come off of northern Mexico, it's going to cross right through Central Texas into North Texas, it will go up through parts of Oklahoma, Arkansas, into the Midwest, and then parts of like upstate New York and northern New England, they will be able to experience totality. But this is coming right across a good chunk of Texas, so Austin, Dallas, a lot of these big areas. This is why Texas is getting a lot of the attention for this upcoming solar eclipse. I think NASA is going to have a team here in Kerrville, so there's going to be teams like on a national level which are paying close attention to Texas. This is a closer look at the path of totality in kind of this local area. So Austin and much of the I-35 corridor, just barely in the path of totality. So we'll get into the timing, but essentially for Austin, there's going to be less than 2 minutes of totality, whereas here in Blanco, there's going to be more than 3 minutes of totality, and for places like Burnett and Marble Falls, there's going to be like 4 minutes or more of totality. So based on how close to the center of this path of totality you are, or again the umbra, this direct shadow of the moon, you get more totality. And even though 4 minutes is a long time, it's very quick. So I remember this from the partial solar eclipse that I experienced in Georgia. I'm glad that we're all sitting here talking about it today, because if you don't really know like what to look for and what to expect on the day of, it all happens very quick. You're like, wait a minute, that was it. So we're going to talk about what exactly to expect. So this just shows you, I just thought this was really interesting, how the path of the annular solar eclipse and the path of the total solar eclipse that we have coming up in April, they intersect. So I just thought that was really cool. I wanted to show you guys that. Okay, let's see. I'm going to try to load this real quick. This was a video that we had of a total solar eclipse in Antarctica. We'll see if this loads. Sometimes YouTube gives me a problem. It's not going to load. But what it shows is how there's a time lapse of how it gets darker, not completely like pitch black, middle of the night dark, because you still have like surrounding areas that are not totality that have more normal light, but it gets much darker, like late twilight is how I would describe it. And in Antarctica, when there's no other like outside light or anything, it's just really cool to see. So if you'd like to on your own time, you can look at that. Okay, so when exactly will the total solar eclipse happen? So as we talked about, this is very important for these eclipses because for totality, you're going to have a couple of minutes, so it's important to know, okay, when is this happening? How long do I get to enjoy this for? When does the partial eclipse begin again? So let's start with the timing. This is the time that totality begins. The partial solar eclipse is going to begin much earlier than this, so we'll talk about that. But here at Blanco, it's going to be just before 1:34 p.m. in the afternoon. Yeah, but take a picture. So for Austin, it's going to be like 1:36, and you can see there's not a huge difference, right? But there's a small difference depending on where you are. So for Blanco, 1:33:48, 1:34:52. For Burnet, you can see that there's a little bit of a difference here. And unfortunately, for Arcadia area, I've kind of highlighted, we have these 13 counties that we cover. That's our DMA. So for the I-35 counties and the Hill Country, this is going to be awesome. For folks who watch us in Bastrop or Fayette County, it's not going to be as cool. They'll get partial solar eclipse, which is still nice, but it's going to be much more impactful for these areas in the immediate path of totality. So that is the time that totality begins. Once it begins, how long is it going to last for? This is the time in totality. So as I mentioned, just how close you are to the exact center of this shadow dictates how long you'll be in this darkness for. So for Austin, it's going to be on the lower edge of the spectrum, 1 minute 46 seconds, and then for like eastern and southeastern parts of the metro, there's going to be some areas that actually kind of get out of totality. But then the more that you go west into the Hill Country, Dripping Springs, 2 minutes and 58 seconds, 3 minutes and 37 seconds here in Blanco, which is going to be just spectacular. And then there's some places like Llano and Burnet that are like over 4 minutes and 20 seconds of totality, and then out towards like Fredericksburg and Mason. So you see why we have people from all over the world who are flocking to Central Texas, because we have some of these really good times that will be spent in totality. That's actually something that we're trying to figure out at the TV station, like where do we go? How do we get out there? They're like, you need to leave like 6 hours early. I'm like, I might need to leave a day or two early. But this is the time that will be spent in totality. So totality, that is the part where the moon is going to be completely covering up the sun, where it's dark, where you can safely remove your eclipse glasses and you can look up and you'll see a number of things that we'll talk about. The partial solar eclipse, those go to begin much earlier. So I just pulled the numbers for Austin. The start time in Blanco is going to be very similar, but the partial eclipse is going to begin just after noon at about 12:17. So just like what we had with the last partial eclipse, even though totality will be reached, when the partial solar eclipse is happening, to look up at the sun, you still need eclipse glasses. Kids ask me the craziest questions about this, like, why is it so dangerous to look up at the sun during an eclipse? I'm like, it is always dangerous to look at the sun. Like, no, if you went outside right now, you looked at the sun for 5 minutes, you would be blinded. So there's nothing special that happens with the sun during an eclipse that makes it more dangerous. It's just this is the time where we feel the need to look directly at it. So the partial eclipse will begin at 12:17. Again, in Austin, right around 1:36, 1:37 is going to be totality. So the total duration of the partial and totality will be 2 hours, 41 minutes, but within that, the totality, again, is just going to be like 2 minutes or 3 to 4 minutes across parts of the hill country. Okay, so we talked about when it's going to happen. Now I wanted to walk you guys through some of the things to look for. And when I went into this partial eclipse in Georgia, this was something that was like really helpful for me. Again, this stuff is happening fast, and if you know, okay, we're leading up to totality, this is what I should be looking for, this helps a lot. So in the lead up to totality, so this is what we expect in the few minutes leading up to totality. First, let's talk more about shadows. So this is the same picture I showed you earlier, but you have kind of two effects with shadows. You have what's called shadow bands, and that's this kind of cool, funky looking shape to the shadow. Again, it makes sense if you have just like an orb light versus a light that's a crescent, it gives you different shaped shadows. And there's a few other things that are happening with like the light entering our atmosphere that scientists are still trying to figure out why the shadows look like this. And then beyond that, you get these sharper shadows. So instead of these kind of fuzzy outlines, you may look at your shadow on the ground, you're like, wow, that's like really crisp. One of the ways that I was reading that kind of described this, it's like, well, instead of like a fuzzy orb in the sky, now it's more like a glow stick or something like pointed directly at you. So you're getting more direct light, so the shadows, they're just going to look different in the lead up to totality. So that is certainly something to look out for. Now, in the minutes and seconds leading up to totality, you will see something like this, and this is what we call Bailey's beads. So you get these little bead-shaped little pockets of light, Bailey's beads. And what you're seeing here is the last little bit of sunlight that's going through the mountains and valleys on the moon. So you're seeing kind of the topography of the moon, which is giving you this Bailey's beads effect. So this is really cool. And a lot of you, I'm showing you pictures, you're like, oh, okay, well, there's going to be lights up there, that's cool. When you see this in person, I think it's going to be a lot more impactful. Like, wow, okay, this is actually light that's coming through the moon. So Bailey's beads, this will be kind of in the lead up to totality. And then eventually these beads are going to become kind of like a diamond shape for a second. And when you start to see that diamond, that basically signifies that totality is starting. So once you start to see Bailey's beads, then this little kind of like diamond flash, then you know totality has begun. You can take off the eclipse glasses. But Bailey's beads are going to be really cool to experience. What you will also perhaps see is this kind of red arc along the edge of the moon. So what that is it's actually what we call the chromosphere, which is like the middle atmosphere of the sun. So because we're having so much of the sunlight that is blocked out, we're actually with the naked human eye going to be able to see things that normally we would not see, and even if we could see, we wouldn't be looking up at. So when you start to see this kind of red, pink, orangish color, that is actually the middle atmosphere of the sun. They call it the chromosphere, which is going to be really cool. So that is in the lead up to totality. Again, in the lead up to totality, we still need our glasses on. But once totality has been reached, we see Bailey's beads, we see this diamond, we've seen this red arc. Well, now we can take off our glasses, and this is where things get really, really cool, and you get this kind of like once-in-a-lifetime experience. So, things to look out for. During totality, you can look around, and the sunset is going to be pretty much 360 degrees. So, right, like on a normal day, you look, okay, in the west, we've got the sun that is setting. Here, we're going to be able to look pretty much all around, and you're going to see this twilight or sunset effect, which is going to be really, really, really cool. You will also be able to see what is called the corona of the sun. And for the naked human eye, this is literally the only way that we are able to see this, is during a total solar eclipse. So at this point, the entire sun's blocked out, right? But this kind of, they describe it as like a spider web almost, this kind of white spider web, cobweb looking thing, that is the outer atmosphere of the sun. So we've got the chromosphere and then the corona, which you'll be able to see during totality. So again, this is always just kind of cool to me. This is the only way that you're able to see this is during a total solar eclipse. So look up at this point. So at this point, we've got no glasses on. We can look up safely. You'll be able to see the solar corona. A few other things that you will likely notice. The temperature will drop. So even during the partial eclipse back in October, where Austin had 89% totality, I was looking at the temperature dropped 4 degrees. So, I'd be so mad if it's cloudy. I really hope it's not cloudy. Depending on the weather and how much sunlight that we have before, the temperature is probably going to drop like pretty substantially. Like it could be maybe 8 to 12 degrees, so that'll be a fun thing for me to figure out my forecast for that day. But the temperature will drop, which will be really cool. And then also, birds and animals, they start thinking, you know, they don't know the eclipse is happening, they start thinking it's nighttime, so it can get really quiet, or birds that chirp, or bats and stuff that will be flying. Animals are going to start getting confused, so you might start to see some weird stuff going on with the animals. So just a few other things to look out for during totality. Okay, so another thing that I wanted to talk about was safety during the eclipse. So as we mentioned, I think a lot of people get confused. They think, okay, this is a total solar eclipse. Well, forget the glasses. I don't need eclipse glasses. You do not need eclipse glasses during totality, but that is only like a 3 to 4 minute stretch in the lead up and following totality. If you still want to be able to look up at the sun and see what's going on, you do still need solar eclipse glasses. So just to kind of a few things to keep in mind, you'll still need solar eclipse glasses to view the partial eclipse, which starts just after noon in the lead up. But then once you start to see the Bailey's beads and the diamonds, and then you know totality's happening, then you can take off the glasses, then you can look up and you can see the corona of the sun. So if you missed this one, what is the next one? It's going to be waiting a while. The next total solar eclipse for Austin is not until February 25th, 2343. So I recommend enjoying this one. And, you know, what's kind of interesting is, I mean, I guess it's really more math than anything else. We know the orbit of the moon, we know the orbit of the Earth, we know the placement of everything, so they're able to calculate this out like pretty much indefinitely when the next eclipses will happen, and they're able to go backwards and see when the past eclipses were. So the next one's going to be 2343. And with that, if you guys have any questions for me, I will answer whatever you would like. Questions about weather, questions about eclipses, I'll talk about anything. Yes?
My sister and I are having this argument.
Yeah.
She lives in Comfort, you know, I live here in Blanco. Who is closer to the total solar eclipse? Who has it better? Solar eclipse?
I don't want to break up any families here. Here, let's go back to our graphic here.
I'm filming this so I can prove to her.
I support your family. You're both going to have a great eclipse experience. Wait, so this is the start time. Let's go to the next one. So you can pick it out of the map. Yourself and see.
Yeah.
It's going to be very similar.
And she can't find you, so you can say, you know, if you want to skew this.
Put me on the spot. I hope your family has a wonderful time doing it. Any other questions?
How much would cloud cover interfere with what we see in the
Yeah, so I've also been getting this question. The eclipse is going to happen whether it's cloudy or not. Like, it's going to happen. And it will get darker during totality, whether it's cloudy or not. The extent to which it's different and we're able to view the partial eclipse, though, that depends on cloud cover. So if it's cloudy, it's going to get darker, but we're not going to be able to look up and see the corona and the Bailey's beads, not because it's not happening, but because it's just going to be covered in cloud cover. So knock on wood, hopefully that does not happen. If it is cloudy, it's going to drastically decrease how cool it is, but it's still going to be kind of cool to experience. It will still get darker, it will still be like night, the temperature will still drop. We're just not going to be able to look up and see some of these cool things with the naked eye that you wouldn't otherwise be able to see.
Okay, so you're looking through your glasses,
Yes.
you see Bailey's beads. At that point, you take your glasses off,
Yes.
and then the eclipse is there. Then when it starts to revert, do you see the Bailey's beads again?
So I think for a short period of time, yeah, on the other side, you'll be able to see the topography on the other side as it moves out. Yeah, and that will be kind of a signature of like, okay, all right, time to put the glasses back on. Yeah, so here in Blanco, with like over 3 minutes of totality, though, we'll actually have time to. In Austin, it's gonna be kind of quick, like a minute and a half, minute 45 seconds. It'll be like. but here it's going to be really cool. But yeah, so I do think you'll see Bailey's. I think it's going to be more pronounced on the lead in, but you should see that on the reverse side too as it starts to end. Yeah.
Do you recommend any kind of these glasses, and are any of them better than others? Well, I'm just looking at some on Amazon here, and some clear lenses which don't make any sense to me at all.
So as long as they're like certified eclipse glasses and not just like sunglasses, they should be fine.
There's any of them?
I should have started the eclipse glasses brand a
Yeah.
few years ago. Yeah, but so some people have always been like, what about sunglasses, or can I point my phone up? Like that stuff doesn't really work. Yeah, so I would recommend eclipse glasses. And those could be, as we saw with the partial eclipse, those could be very hard to come by like the day before. So yeah, if you're like on Amazon right now, you just like get an order right now. I think that's probably the best. Yeah.
Is your presentation slides available somewhere to show to relatives and friends?
Sure. I can. I'll send that to you, and you can share the link if you'd like. And then I guess this is being recorded too. That will be shown at a later date. Yeah, I'll make sure you guys can access them. Yeah.
Would you like to talk a little bit about the millions of people that could come through?
So that is beyond how cool the celestial event is going to be. Yeah, like a lot of these small towns where you have this influx of tens of thousands, if not over 100,000 people. I think it's going to be kind of a mess. Like just the traffic. That's like we're trying to plan this out. I'm trying to find a spot to be out here, like not in Austin, in the hill country, so we have more totality. We're going to do like a stream and stuff. And so I've been trying to figure out where to go, and it's very hard to do that. And then even once I figure out where to go, I've got to like get out here. Where do I put the car? So I think it's going to be it's going to be crazy. It's going to be all.
You need to spend the night too, then.
Truly.
I think they should just have a copy.
Yeah. I'll talk to Katie, see if we can get that. Okay, we won't pay you for the next 5 years, but you can have a helicopter. Yeah, I think it's going to be crazy. I mean, it's not all negative. It's a good tourism boost for towns like this. But yeah, if you're looking to get a hotel room anytime around the eclipse, you're going to be out of luck.
Oh, yeah.
I have a question. I was an Air Force brat, so we lived in Warner Robins.
Yeah, no, I won't.
I thought you might. When was the last time they had a solar?
It was in the fall of 2017. There was totality. The totality like didn't pass directly through making a Warner Robins. We were like very close, like 98, 99%. Yeah, so 2017 was that one. That was the first year I got to Macon. Yeah, Warner Robins is a cool place. It's so interesting. I'd go talk to schools and stuff in Warner Robins too, and like, in Macon, kids are well behaved and stuff. But then when you go talk to a military community, those kids they're on point. Raise their hands. It's crazy.
We were there in 55, and we had a fairly decent. A 55 or 54.
It had an eclipse.
Not total, I don't think, but
Oh,
very close.
Yeah.
And I wonder if can I just look that up somewhere?
Should be able to. I can look it up after we finish the presentation. Yeah, you go back and they're able to like trace
I'm
it
sure they
backwards.
can.
I would just think too, like in 1397, like if you had,
Yeah.
you would have no idea. You'd be like, what is going on? How crazy it would be back then.
Well, since you told us about what it's going to be next, that really makes you know that all these people that really want to see it are going to be looking for it.
And that's why you think like, okay, it's kind of crazy to like travel from around the world to see this, but then when you see the rarity of how infrequent it is, and you say every year and a half for some place on the globe, well, what if 90% of the path is in the ocean? Like, it's not always viewable in this way. So it's a really unique experience. Like when I first got the job at Austin, like they were already talking about this. They're just like, 4 years ago, like we've got this like total solar eclipse. It's going to be a big deal. So it's a big deal, and it's really cool that we get to experience this.
Statistically, April 8th, what is the cloud cover percentage?
So in the spring, like what would be like fairly like common would be like we have like some low clouds in the morning, and that kind of lifts into the afternoon. I wish I could tell you exactly when the weather's going to be. That would be like fairly common.
This is
With our luck, we've got this like 4-year drought going on. There's been no rain for 4 years, then it rains all day. I think.
And several showers.
Yeah, but you know, even if it was say like, if it's overcast or kind of out of luck, but even if it was like partly cloudy and you have like the top peaks where you can look up at it, like that'd be better than nothing. I hope it works out for us. This is the part where I have to say I don't control it. I just talk about it.
You just recorded.
Any weather questions, want me?
So this is an El Nino year, and we have gotten a little more rain than we've had in the last
For sure.
few years. Not a bunch of it. I mean, does that affect how it's for the weather?
Yeah, so this winter was a strong El Nino winter, which especially, unfortunately, this I-35 corridor in the east has had tons of rain. You know, the Austin airport had a foot of rain this winter. If there was a foot of rain in Blanco and Gillespie County, we'd be in a lot better shape with our lakes and drought and everything. So this strong El Nino pattern definitely delivered more rain for some spots. Unfortunately, here and for parts of the hill country that really needed it, there's a little more rain, but it was just not to the extent needed to make like a huge difference. We are now about to transition back from El Nino to another La Nina, which is what we just finished up for 3 years. So in these kind of transition periods, I do think this spring will be pretty active with the storm threat. That does not necessarily mean like tons of heavy rain, but I do think we'll have a couple of severe weather threats compared to last spring, which was relatively quiet severe weather-wise. Outside of a couple of hailstorms, we really only had like one confirmed tornado for all of 2023. So I think severe weather-wise, it's going to be a bit more active. And then, unfortunately, as we go back to La Nina, like we talked about for the last 3 years, that tilts the odds back towards hotter and drier weather, especially during the summer. So I do think summer is going to be really hot again. But one thing, as we go back to La Nina, I think this hurricane season is going to be really active. So it's impossible to know where exactly every hurricane is going to go. But it's really been since like 2017 Harvey since we've had any sort of like significant tropical impacts. Certainly not guaranteeing a tropical impact, but that's another kind of thing that could throw a wrench in the late summer forecast if we were to catch a tropical system, and that could help with some of our rainfall issues. Yes?
Is there a specific type of telescope lens that I should use for the instruments?
Yes, and I do not know what it is off the top of my head, but there's definitely, for cameras, there's like a special like lens attachment you can use, and I think it's the same for telescopes. So yes, you do need that to safely view like through a camera or a telescope. I wish I knew off the top of my head what that was, but you do need a special lens. A lot of people too like to try to like point their camera up at it. Like you can't do that. A, it's not going to look very good, and B, I don't think it's good for your phone.
Is that it, everybody? Well, thank you very much.